All right, today we are doing section 1.5. We are going to be rewriting equations and formulas. Our objective today is just to rewrite literal equations. In order to do that, though, we need to be able to solve regular equations, so that's what our warm-ups are about. Our first warm-up, how am I going to start solving for x? Hunter?
Add 5 on both sides.
Good. Add 5 to both sides of the equation. That leaves me with 2x equals what?
Negative 6. Oh, wait.
Negative 6. Who can tell me my next step to solve this? Divide by what?
2.
2. What do we get for x? Dominic?
Minus 3.
Good, a negative 3. Very good.
Mm-hmm.
Okay, on number 2. Who can tell me my first step? Jermila? Very good. We need to distribute that 3 into those parentheses first. When I distribute, what do I get?
Minus 6.
Good. Still equals
8.
x plus 8. Don't drop that x. Now we've got x's on both sides, but we want them all together. So in order to combine, we need to force them to be by each other. So somebody was saying it. Subtract x on both sides will force all of our x's to be together. So 3x minus x gives us what? 2x. Still minus 6. What's still on the other side of the equal sign? 8. Okay, next step to solve. Add 6 on both sides. 2x equals 14. Last step. Divide by 2. X equals. Good. Today, we are still going to be solving equations, but this time it's not going to just be a number for our answer. So our answer will still be an equation. It'll just have one of the variables alone. All right, our notes for today, rewriting literal equations. An equation that has 2 or more variables is called a literal equation. To rewrite a literal equation, solve for one variable in terms of the other variables. So what that means is you will get one of the variables alone, but the other side of the problem or the other side of the equation will still have variables in it. All right, we are going to solve the literal equation for y. So all that means is get y by itself. Get y alone or by itself. So we want our answer to be y equals whatever the other side may come out to be. So if it helps, you can put a box or a circle or something around y and act like you're trying to get y alone and think about what steps you would take. Anybody have any ideas? Z, what do you think? We would not. The 3 and the y are getting multiplied. So I would not subtract 3 on both sides. Hunter, what do you think?
Divide, I think.
We would divide eventually. Lydia? Good. We need to get rid of this minus x. So in order to do that, we would add x. Just like if we were subtracting a number, we would add the number. We treat it the same way. So we add x on both sides. What do I still have on the left side? A 3y. What is on my right side? 9 plus x or x plus 9. Can I write that as 9x?
No.
No, because 9x implies what operation? Multiplication, and we're not multiplying, we are
Subtract.
adding. We put a plus sign there, we better be adding. If you would rather write it as x plus 9, that's fine, but I'm okay with 9 plus x. Now, Hunter, what do you think we should do? Divide by 3. So we're going to divide both sides by 3. If you have a lot going on one side, you just put a bigger division bar or fraction bar. We're still just dividing by 3. And then that ends up being our answer. There is a way to simplify this if we were to break up our division bar. So I will show this to you. I am not necessarily expecting that we have to do it this way. If you were to give me y equals 9 plus x all divided by 3 as your answer, I'd be fine with that. But if we split up our division and divide both 9 and x by 3, what could simplify? 9 over 3 simplifies to be what? 3. So this could become 3 plus x divided by 3. I would be okay with either one of those answers. Okay. Later on in the year, we will have to do it this second way, but for now, I'd be okay with this first way. We're just trying to get y alone. Questions on 1 before we do 2? Okay, on 2, again, our goal is to get y alone. Any thoughts on a first step? Dominic, what do you think?
It's just subtract 4x.
Good. I heard a couple people say it. Subtract 4x on both sides. Now we need to be careful. What does that leave us with on the left side? Good. Do not drop the negative sign from that 7. And what would we have on the right side? 12 minus 4x. Remember, we cannot combine the 12 minus 4. Why not? Good. They are not like terms. We cannot combine them. What's my last step to get y all alone? Divide by? Negative 7. Make sure you are dividing by a negative. So y equals 12 minus 4x all divided by negative 7. Technically, we could split up the division, but nothing is going to simplify, so I just wouldn't even bother on this one. You got y alone. That's what the directions asked us to do. We'll leave it at that. Questions on 1 and 2 before we move on? All right, on 3 and 4, they switched up the directions on us. This time, we are solving for x. What can I do on number 3 before I get started solving? Good, Brian. Combine like terms. What can I combine? Okay, those x terms can be combined. They're on the same side of the problem. So we can go ahead and combine. We get y equals 1x. Is there anything else we need to do to get x alone? We could divide by 1. Is that going to change anything? No. So if x is alone, I'd say you're good to stop. So you could either just circle that, or if you like x to be on the left, you could flip it around. Either way, that's all it took to get to our answer. All right, number 4 is going to be a little bit different. We're trying to get x alone. Janiyah, what do you think? Good. We subtract 3 from both sides to get started. What do I still have on the left side? 5x. And on my right side? Y minus 3. To get x all alone? Divide both sides by 5. So now x will be alone. Again, our answer is just a big fraction. Splitting it up won't simplify anything, so might as well just leave it alone there. Questions, concerns before we move on? Okay. All right, on these, we are going to do each problem 2 times. The first time we'll solve for x. The second time we will solve for y. Go ahead and get these copied down, and why don't you go ahead and start trying at least number 5 on your own. So if it helps, you could write the problem and then write 2 columns. One of them where you're going to solve for x, and the other where you're going to solve for y. All right, let's do our solve for x first. Anyone give me their first step on solving for x, Janaya? Okay, we could subtract 4y from both sides. Subtract 4y. Usually, if we're trying to solve for something, we want to leave it where it is and move everything that was around it. So subtracting 4y is a good first step. So that gives me 20 minus 4y equals what? 8x. What would be our next step? Divide by 8. On this one, I am going to split it up just to show you. If we divide this by 8, we divide both of these other terms by 8. If you do the one big fraction bar, it means the same thing, but this sets it up for us to simplify a little bit easier. Okay, so we know that the 8 over 8 is going to do what? Cancel out completely. That's what we wanted. 20 over 8 will also simplify though. 20 and 8 are both divisible by what? 2, but bigger than 2. 4. What's 20 divided by 4? 5, and 8 divided by 4 is 2. Minus 4 over 8 will also simplify. What are 4 and 8 both divisible by? 4. So 4 divided by 4 is 1y over, yes, 8 divided by 4 is 2. And all of this is equal to x. Now, if you had 20 minus 4y, the whole thing over 8, I'd probably give it to you. We could, because these denominators are the same, we could smush this back together and have 5 minus y over 2 equals x. There are a few different acceptable answers at this point. Okay, let's solve it for y. So this time the 4y for now needs to stay put, and we need to move what? We need to move the 8x. How are we going to move it? Subtract it. Minus 8x on both sides. So 20 minus 8x equals 4y. To finish getting y alone, we need to divide by 4. Since all of these terms are divisible by 4, I'm going to go ahead and split up my fraction and divide every single piece by 4. 20 divided by 4 gives me 5. Minus 8x divided by 4, 2. X. We should still have an x with it even if we divide. And now it equals y. Again, if you were to put your big fraction bar and not simplify yet, I'd probably still accept it, but this one does simplify really nicely. So I do prefer it that way. But if you got the big fraction bar, as long as y is alone for now, we'll be fine. Later on, we will have to be able to simplify them though. So we might as well try it out now. Okay, questions before we move on to 6? Janaya?
So, the solve for x, you have to have the 2s under it?
Yes, there should be 2's here. If we changed these to 5 and 1, we should have a divided by 2. It doesn't simplify quite as nicely as the y one does. Anything else? Okay. On number 6, let's do our solve for x first. What's the first thing that needs to move? Add 2y. We're going to leave the 2x where it is. We're going to move the 2y by adding it. So we add 2y on both sides. 2x equals 4 plus 2y. And then what would I need to do? Divide by 2. Can 4 and 2 be divided by 2? Yes. So I would go ahead and divide every piece by 2. If I know it's going to simplify, I might as well make my answer a little bit prettier. On the left, what do I still have? X equals 4 divided by 2. 2y divided by 2 is just 1y. If you want to put the 1 in front of the y, you can. You do not have to.
I just have it like x equals 4 plus 2y over 2.
I would take that for now. I would take that because you would have the x alone. However, we eventually are going to have to be able to simplify, so that's why I'm going ahead and showing it.
What if it's like 5 divided by 2?
Right, if it can't be, like these ones couldn't simplify anymore, then we have to have a fraction. Sometimes that will happen. Let's solve for y. How am I going to start that off? Subtract 2x on both sides. What does that leave me with on the left? A negative 2y. Watch your signs. Equals what? Good. 4 minus 2x. Now what are we dividing by? Divide by a negative 2. This one will be important because when we divide by a negative, what happens to our signs? They change. Okay, which we want to happen here. We want this to cancel out and give us a positive 1y. But if we take 4 divided by negative 2, what do we get? Negative 2. And if we take negative 2x divided by negative 2x, what do we get? Positive 1x. So our signs change when we have to divide off a negative. A formula shows how one variable is related to one or more other variables. A formula is a type of literal equation. Here are some common formulas. You do not need to write these down right now. Okay. We will have some questions about formulas on the next slide, but I will rewrite them for you. But they are ones that, for the most part, we should already be familiar with. Okay. Area of a rectangle we've dealt with in this class. A equals B times H, or sometimes you might see it. Anybody know it? Thought you might have been saying it. What? B times H is what they have, but there's a different one.
Length times width times height.
That's volume. Area is just length times width. Yep. Okay, perimeter, 2 times the length plus 2 times the width. Distance equals rate times time. That's one we've definitely talked about a couple times in word problems. The last one, simple interest. I is equal to P, which stands for the principal amount, times the rate times time. Okay, again, we don't necessarily need to know how to use these yet, but we are going to be solving some of them for a given variable. So in this case, we are solving the distance formula, which is D equals RT, so I would write that down this time. And we are going to solve for R. So when we are solving formulas as literal equations, many formulas don't have numbers involved at all. So we have to be able to just manipulate these with only variables. What's going on between the rate and the time? What operation? Multiplication. How do we undo multiplication? Divide. So if I'm trying to get r alone, what should I do to both sides? Not divide by r. Divide by t. We want to leave the r where it is, and we want to divide both sides by t. So on the right side, the t's cancel out. Distance divided by time is equal to the rate. Or if you want to flip it around, rate is equal to distance divided by time. That one was pretty easy, just one step, one thing to move. Questions, concerns? Okay, we ready for another one? Solve the simple interest formula for P. So that one was I equals P R T. We are going to solve for P. So we're trying to get P alone. What do I need to get rid of? The R and the T. Both R and T are being what? Multiplied to the P. So to undo that, we need to divide. You can go ahead and divide by both of them at the same time. That's fine. So on the right side, they both cancel out. So we have I divided by RT is equal to P. If you wanted to flip it around and put the P on the left, you can, but you do not have to. Questions, concerns about this one? Nothing? All right, I do want to do one where we use the perimeter formula. So let's just solve the perimeter formula for length. We'll solve it for L. So I write my L's lowercase cursive because to me, regular lowercase L's sometimes look like ones. But either way, this is what we're solving for, is this L. That's what we're trying to get alone. First thing I should do? Do what? Good, we need to move the 2W, subtract 2W. So we have P minus 2W equals 2L. Trying to get L alone, so we still need to divide by 2 on both sides. Again, if you want to put one big divide by 2, technically that's fine, but we can simplify this a little bit. So I'm going to go ahead and split it up so I can simplify. So when I do that, the P over 2 will not simplify, but 2W over 2 is just a W. Those 2's cancel each other out. And again, by the L or the length, the 2's cancel out. So then we have length alone. If they're telling you to solve for a variable, it doesn't really matter to me if you get it alone on the left or the right. It just has to be alone. All right, our homework assignment, we are getting back into our textbook. So write this down either on your notes or on your planner.